So now if we run the full thing, we can run it real quick, and we can kind of speed it up, and we can see how it's going to do all the cutouts. There we go. There we go. See, obviously our corners down here were too narrow because you can't quite get in that one over there. So no problem. But you see, yeah, see, like even now we didn't, because we used the contour, not the adaptive, that left these little corners. That's fine. This is something we could cut off in the bandsaw too before we flipped it over. You probably want to cut those off. Again, when you do the facing operation on the other side, it's you don't want like you would try and want to avoid like flying chunks of metal, you know, so when it's facing off, it's going to like fling off, you know, this piece of metal off into the machine, and it's probably going to be fine, but better to be safe. And so we can just like, you know, cut a little bit of this off in a bandsaw, and then you're fine, even these little corners, and it gives less things for like the machine to catch on to, you know, and potentially rip out your part from the vise. And so now, really, I mean, it's not done yet. So the way I would do it, right, going forward, I'm not going to do all the toolpaths for you guys, but you guys get the point. I can do a drilling toolpath real quick for you. Let's do this, a drill toolpath. We don't have the right tool drill in here. This will be a 43 size drill, but it actually doesn't matter. I think there is actually with the, I think it's tool 12. All right, that one is actually in there right now, a 43. But for this particular toolpath, I think I thought I changed that. Well, I think I changed it on my other one here. Oh, here, yeah. So see, tool 12. It said the name says drill number 11. But if you look under diameter, I did change it to 0.089, which is a number 43 drill. Real quick on that note, just to show you guys, I should have it. Yeah, this is a great site. I can post this in the chat. Let's see here. Where's chat? Oh, people are chatting, telling me how my issues I'm having, huh? All right. So, oh, I guess I just did 2 Jonathan Lim. Let's see here. All right, there we go. All right, so that's a great resource. Like as you see, I have it in my favorites up here. But this is like a drill tap guide. So these are all your metric tools. These are your imperial size. So say like we're going to drill 440 holes. So if I go 440 and then I go to aluminum, so that'd be a number, I would drill a number 43, and the hole would be a 0.089. If I wanted to drill a clearance hole, like I wanted the screw to go through the hole and not threaded, I would use a 32 for a close fit, or a number 30 for kind of a looser fit, depending on my tolerances. So like this is a really handy guide to have. It's one of the easier ones I found to read, and again, it has all your metric and I found it also to be very accurate. Like I have lots of success, you know, tapping holes with this with these sizes. Some are a little bit different, and then there's another one which I'll show you. This will be. We'll find that one. It's I can't find it right now. Oh, here it is. Countersink calculator. Let's click on that one, and I'll post this one too. So this one you'll use on the Bridgeport to calculate a countersink. Let's see, chat. I always go to Johnny. All right, so now you guys should have access to that, but this is kind of handy too if you're like, you know, trying to figure out like, say, like how deep to go with a countersink bit to just be right for your screw. You measure the diameter of the head of your flathead screw, and then say it's like 0.2 0 or something like that. And then the angle of your counter of the head or of your countersink, which is usually it's shoot, now what is it? Is it 89 degrees? Or no, I mean, let's just say 90 for now. A 90-degree angle, you know, to 82, actually, that's what it is normally, 82. And we calculate that. So my Z distance from the tip of the countersink would be to go into the material 0.1208 inches. And that would give me, you know, exact diameter at the surface of 0.21. So that's pretty handy to use to set your countersinks correctly. So anyway, back to this. So drilling a hole. So we'll set, you know, drill number 11. I can select this. The nice thing is it has this little checkbox, select same diameter hole, selects all the holes. So now if I go to my depths, depths here, sorry. Go to my depths. Now, this is what I was talking about for the drill tip through bottom. See, if I just left it the way it is, the drill tip would hit the bottom and you would still have this material on either side. So I'm gonna go drill tip through bottom. And then I might even add a little extra on there just to be safe. So if I do like even say 0.1, which is fine. It's gonna go way through it, but I'll have clean edges. So I'll do that. And then there's nothing really here you can do. If you rapid drilling in this case is fine. If you're doing a really deep hole, chip breaking, partial retract, it will kind of like woodpecker itself down, like keep going in and out, and so it cleans out the hole before keep going, and so it helps with the coolant. As you're spraying the coolant on there, it will clean out the chips better. But for a hole like this, the only problem is the most stress on a drill bit is when it starts to cut. So when you're using like chip breaking, partial retract, you're putting a lot of extra stress on the drill bit. Once it's in the material, drill bits do pretty good. It has less stress than when it first starts cutting. So just doing a regular drilling rapid out is fine. Sometimes here though, again, because it's set up, you know, for the last tool, I just want to check my feeds and speeds for this, because depending on when you switch out drill, you're going to want to adjust that. So I'm going to leave it at 3,000 RPM, but I'm going to drop it down to about 15 inches per minute plunge rate for this smaller drill, and that should be fine. All right, we'll do that one. So again, you guys get the idea. You're gonna have to play again with some of this stuff, but use the tools that are in the library already. There are some smaller end mills, like for this little guy here. You're probably, like I said, gonna want to do a plunge or not. You're gonna want to drill a hole in this one, and you can use that other. Let's see. I guess I need to use this one. Hide this real quick. See here, where's here we go, tool library. So you're probably going to want to use this other drill, and that one actually is in the drill or in the machine right now. That's 0.196, and that one works pretty well for drilling a hole right here, and then you use like a 3/32 end mill to come in and clean all this out. So that's about all I'm going to teach you in terms of tool paths for now. Like, part of it is for you guys to get hands-on with the software and practice it yourselves. I did want to try and quickly do something with the Bridgeport Mill. So the Bridgeport Mill with the ProtoTrack controller, it's a 2-axis CNC mill, which means it has X and Y but no Z. The Z is manual, so you have to, move the quill down manually. So that's good and bad. One, it's much harder to crash the mill, the Bridgeport, than it is to crash the Tontai. So if you crash the Bridgeport, you're really not paying attention. There's really no excuse for crashing the Bridgeport, because there's lots of steps you can take prior to make sure you're not going to crash. So anyway, but the problem is that we want to still be able to use CAM software to do the toolpath instead of sitting there and pressing all the buttons on on the display. You can program it on the display, but it takes forever, and it could lead to actually more problems. So in this particular case, all I'm going to be doing is I'm going to be countersinking the holes on this, and then I'm also going to be chamfering the edge, the top edge. And so as you can see, let's see how I did this. I guess I did kind of from the bottom. That doesn't matter. It's symmetrical. How did I do this? I didn't. Okay. There we go. Right orientation. All right. So as you can see, I don't have either of those things modeled. I don't have the countersinks modeled, and I don't have the chamfer modeled. And that's intentional. And so what you do is actually, to do the chamfer, you would do a contour toolpath like this. I'm going to open edit because I already have it done here. And then you're going to select the 45-degree, quarter-inch 45-degree chamfer. And then when you do that, it brings up, when you come over here to the passes tab, it brings up this chamfer option. And so this is where you can set your chamfer width. And that's, just like the size of the chamfer, and then your tip offset. And you want to make sure you set a tip offset, because else it's going to cut with the very tip of the tool is going to be at the bottom of the chamfer. So obviously the very tip of a chamfer tool is the weakest part of the whole entire tool. So you want to cut up on the chamfer as much as possible. But obviously we have to think about that this part is going to be held in a vise, right? And this one doesn't really have any stock. The stock is the thickness of this part, because we're going to laser cut out this 1/8" material and then bring it over to the vise, or over to the mill. And so it's 1/8" thick part, right? So we have to hold on to it a little bit, and then still make the pass around without hitting the vise. And so we're going to offset that tip just a little bit. If we had a bunch of stock down here or something, you could offset it a lot more and use a higher part of the tool, which will give you a cleaner cut, because it's more rigid too. But we'll leave it like that. And so now the most important thing to do is when you do your simulation, I'm going to start it and then pause it. And now let's pause it. Now we're going to look right down at the tool here. And so you can see kind of how much material is going to come off this chamfer. And so you can adjust that by adjusting the chamfer width, and then it will move the tool down. And now you can see that tip offset. Now I'm not cut. The tip of the tool isn't right here at this corner. It's a little bit offset. And so I probably could move it a little bit lower and still not hit the vise, but I wasn't sure of, what size of parallels we had, how much I could grip this thing. So this worked just fine to give a nice chamfer, clean chamfer. So that's great. So you would also need to do another toolpath just for drilling holes. And then that's just going to be, because again, the Bridgeport doesn't have a Z axis. So you're going to manually move the quill. And so you could do a toolpath for drilling holes, and then we'll edit the G code and then you'll just manually bring down the quill to the right height for a countersink. So the problem with doing toolpaths in Inventor and then exporting for the Tontai is there's no option to say for 2-axis CNC. So anyway, when you're done with your toolpaths, there's a couple things you can do. One, say you can export each toolpath, and it's called post-process. You click on that, and for the Tontai CNC, the controller on it, the computer, is a Mitsubishi controller. So you select Mitsubishi. The one thing you need to probably set in your software is this Preload Tool, no. And so we don't, some machines have like an arm that changes tools. And so it can load and offload a tool at the same time. And so if you say Preload Tool, it will as it's working, as it's, you know, running a toolpath, it will change the tool changer and get ready so that it's a faster tool load. Our machine doesn't have that capability, so you just want to change that to preload tool no. Anyway, so you can right click on the toolpath and export, and you can export it to a thumb drive. And you have to give it a name, but the name has to be like a 4-digit number for a Mitsubishi controller. So you can name it anything. You know, I usually, you know, pick some, you know, say like 5550 like that, and the next one will be 5551, 5552, etc. But you can do whatever you want, a number. But keep in mind, you're going to have multiple toolpaths, so, you know, don't make it too complicated. Or so alternatively, if we want the machine to cut all of these toolpaths out, like all at once, like just automatically change tools to the next one, the next one, the next one, then I could just select setup, and I could say post process all. And this is going to put all these toolpaths into one file and go. I don't want you guys doing that right now because your toolpaths will be unproven. So I did cut out mine, and I did it twice. And so I was able to, I did each time I did one toolpath at a time and ran it, and then and ran each one, you know, on its own. And so if there was any error, any issue that I caught, I could just, you know, come back to the computer, adjust, you know, that one file, that one toolpath, and re-export it and run it. The problem is if you export all, and say you get like through, you know, half of these, and then there's an issue and you stop it, you can't start from that place. You got to go all the way from the beginning. So then you got to come back to the computer and like re-export, you know, these toolpaths. So, but if it's for an unproven toolpath, meaning you never run it before, I definitely want you to export each individual toolpath and run them. And so that's just to be safe. If you're making multiple parts and you've confirmed all these toolpaths, then the next time you do it, you can just, you know, right click on the setup and say post process all, and it'll run obviously much faster. You can make the part much faster than doing each individual toolpath, but it's safer to do one at a time. So, but under, let's see, the cover here, I have to do something a little bit different because of the Bridgeport Mill. So I'm going to wrap up here pretty quick, guys. This is the last thing I'm going to show you today. But the Bridgeport Mill, and let's just change this to like, see, yeah, because I don't have that. Let's just say my desktop here. Documents. Save, sec folder 101, fine. I'm going to go ahead and keep this open NC file in editor checked. You don't always need to have that, but I'm going to make sure that the ProTrack machine is selected. It has lots of different CNC machines in here, but for the Bridgeport with the ProTrack controller, we'll use that one, and we'll say post process. And then now, okay, now it's doing this. So I'll just do it to desktop. And now it'll open up the this editor here. So this is G code. Not going to go into a lot of detail on it, but it's basically giving coordinates for the machine. There's some different canned routines. So it's not a bad idea to familiarize yourself with some of the stuff, what these codes mean. For example, like this line is saying, change tool to tool number 4. Obviously, we don't have a tool changer. You're the tool changer for the Bridgeport Mill. So the machine's just going to kind of ignore that one. You are going to have that tool loaded up. This one is start spindle at 7,000 RPMs, and that's going to say start spindle forward. And obviously, we don't have automatic spindle on the Bridgeport, so that's you again. G54 is your work offset. M08 is actually your coolant, turning your coolant on. That, again, we don't have automatic coolant, so it doesn't matter. So G00 is a rapid movement. That means move as fast as the machine can go to these coordinates. And now it's going to say bring Z down to this. We don't have a Z, so it's not going to do that. And then say rapidly move to this Z. And then it's going to say, you know, at a set feed rate, go to this Z again. And then finally, it gets down to Z negative 0.04. So all this stuff here, a lot of this is ignored in the Z, but I need to put in a stop so I make sure that I can set that Z. So what I'm going to do is I'm going to add a line and I'm going to say M00, which is a stop. And then I'm going to say parentheses, set Z, negative 0.04. So now when I run this on the machine, on the mill, it's going to go through all this stuff and it's going to, you know, come to the right coordinates, and then it's going to stop and it's going to tell me on the screen, it's going to display set Z to negative 0.04. And so then it's going to, so I can set the quill, move the quill down manually and set it at 0.04, and then lock it. And then I can press cycle start and it's going to go on to the next lines. And so when I get over to here, I'm going to want to do, say, M00 again, and I'm going to say set safe Z, and that means just bring the Z up, you know, out of the part and make sure it's safe. So in this particular one, it doesn't really matter because as soon as it'll just stop at this point anyway. But say for example, you're drilling those holes or doing the countersinks, you're going to have a lot of movements, right? The machine's going to move over the first hole, and then you're going to need to go down and come up, and then it's going to move to the second one. If you don't set that, the second M00, it's just going to move to the next one while your Z is still down in the part. So you got to be kind of conscious of that. I mean, again, it doesn't matter because where the counters, this particular one, that you know, once it runs all this, it's going to stop. But that's how you edit this G code to run on the ProTrack. And so to load it into the ProTrack, you'll need a USB drive, and it plugs into the back. And then, you know, when we get to that part, I'll show you how to load in the file on the machine itself. But those are the main things to remember here: the M00, set Z, and it's just a pause, and it waits for you to press cycle start before, or the play button in the case of the ProTrack, before it goes on to these lines below. And that's gonna, and the other thing you can do is here, if you go to backplot, it sometimes gives you a very, very basic demo of this. So let's see if it'll, sometimes it kind of messes up. Obviously this is the tool path it's going to make solid animation. There's solid animation. Tool one is interesting. Let's see, show tool. I don't know, this doesn't always work. Well, so that's his basic animation, so not very good. But you can kind of use that anyway sometimes as a way to, especially with the toolpath, to make sure it's kind of doing what you expected it to do. That wasn't a great example, but like this one, you can kind of see that. I mean, same for the holes. You can kind of, if you had drill holes, you would be able to see kind of the positions to make sure you didn't, you know, put in some weird position or something. So once you're done with that, you can just say, you know, save, and now you have that file all set to load into the ProTrack. All right, so I think that's it for tonight, guys. I think I'm gonna go ahead and probably, let's see, stop sharing. Let me stop sharing for a second, and then I guess I can leave the, I'll go ahead and stop the recording, but I'll go ahead and take questions if you have any. And then also I will, if you want to drop off, feel free. I will probably schedule, I might, depending on the questions and some other issues, maybe we can have another one of these video calls. Otherwise, I will post some sign-up sheets for like in-person training. If you're interested, you can sign up. I wanted your names and emails and stuff, because I do, and your which programs you're part of, because I do want to ask, program managers to give me feedback to make sure that you guys are ready to take this, to actually learn on the machine. Because like I said, it's a lot of responsibility. I mean, so take it very seriously. It's like one little mistake and you've crashed, you've ruined a $70,000 machine potentially. So that we're not going to get, and we're not going to get another one. So probably, so it's not something that's fixed quickly or remedied quickly. So I want only people that to use it that are like well trained, and particularly those that are going to use it somewhat consistently, I guess. Like, I don't want you just to use it one time and then say like, I never want to use it again. I probably will on the sign up sheet have something about, if you want to get trained on all three of those machines, the laser cutter, the CNC, and the Bridgeport, or if you say like, oh, I just want to learn how to use a laser cutter, like that's fine too. I can train. That one's not as strict. It's not as dangerous. I'm willing to train anybody on that machine. And then we'll have to schedule some times, after school, to do those trainings. All right. So I gotta see. I think I made it so everybody can't unmute themselves. So let me see how I can undo that. Can you guys unmute yourselves? No, wait. Here we go. Allow participants to unmute themselves. All right, Brandon, what's your question?
Hi, Mr. Huber. So just a quick question. So earlier, before the Zoom seminar actually started, I went to the, I don't remember the name of the website, but the website to download Inventor and the Inventor CAM. Mm-hmm. And me and one of my other friends actually in the seminar had the same problem. So the software downloaded onto the computer, but when we tried to open the file, it wouldn't let us because it said that one or more files that needed to be downloaded with this could not be downloaded and therefore cannot open.
Yeah, so I had the same issue. It's a, what is it? It's like a security issue on your browser. So, okay. So if you Google it, it'll give you the instructions what to change. It's either a Windows security or a browser security problem. So yeah,
all right.
Thanks, Emily. Emily says you have to allow pop-ups, and that's the right answer. So
all right.
That stumped me for a while too until I Googled it. I'm like, oh shoot.
All right.
So that will solve the problem for you.
All right, thank you.
No Mahesh.
Yeah, so where can we find the recording of this workshop?
I will post it. I'll post it probably YouTube, and I'll share you the link. AMSI actually has a YouTube page, a not very frequently used YouTube page, but we have a channel, so I'll post it to that channel. And I'll let you guys know.
Thank you.
All right. Anybody else? Let's see. There's a lot of people here. Any other hands? Any other questions? All right, you guys are ready. You guys are ready to make some toolpaths. So I will probably, I'll post some information. I can post a link in the sign up page, or I'll send an email to also to be able to download those the files if you haven't already got access to them, the blank ID card, as well as the cover. And so I'll make sure that everybody has access to that here before the end of the week. And then I will set up a sign up page for different in-person trainings. I will limit it. Like, I don't want, whatever is in here, 29, but I don't want like 43 people that were signed up to show up to one class. This is a very hands-on, it'll be hands-on detailed training. So I'll probably only train like probably 3 to 5 people depending on the machine at once. But anyway, All right, guys. I hope you learned something. If again, feel free to email me if you guys have any questions, or stop by when I'm on campus and talk about it. But if you have any questions about ToolPass, kind of that you can send me a file or send me email, or make like a screen recording is a good way of doing it too. And I'll try to help you through that. But definitely, I want you guys to struggle a little bit with it, to try to figure it out yourselves. If you can figure it out yourselves, then that's the best way to learn. So, all right. So thanks all for attending. I appreciate your time, appreciate your patience and attention, and we'll talk to you soon.